Welcome again. This will be lecture 2 of EC253C, and today we actually will be discussing microprocessors in more detail. We'll be actually formally starting our unit 1. Unit lecture 1 was all about introduction. We introduced a number of terms. We distinguished between a microprocessor and a controller, and also between a processor and microprocessor. What is a computer and what are embedded systems, how are they related to each other. And then we also discussed that in first unit we will be studying about microprocessors in detail, what they are, how actually they process information, and what is their internal architecture like, what are the different instruction sets of microprocessors. So let me start with microprocessors. Microprocessor. Microprocessor. Let me start with a basic formal definition of the microprocessor. Let me write that down. A microprocessor is a multi-purpose. There are various definitions. Let me write one of them down. It's from your book, Gonker, Microprocessor Architecture Programming Applications with 8085 by Ramesh Gonker. This definition is from this book. So a microprocessor is a multi-purpose programmable clock driven register based. These are all actually properties of microprocessors, and we are going to define and explain each one of them one by one. It's multi-purpose, it's a programmable device, it's a clock driven device, it's a register based device, it's an electronic device, and we can also say it's a digital device, electronic digital device. Okay, enough with properties. Now what it does, it actually reads binary instructions, because since it's a digital electronic device, it only understands binary digits, zeros, zero and ones. So we will say it reads binary instructions. From a storage device. And this storage device is called as memory. Called as memory. And also this microprocessor accepts binary data as input. So it reads instructions from a storage device, we call that memory. It reads instructions from memory, and at the same time it accepts binary data as input. It accepts input, but that should be binary in nature. And thereafter what it does, it processes this data, processes this input data, processes this input data, this input data, according to these instructions which it has read from the memory. what these instructions say. It will process the incoming data according to these instructions and provides results as output, and that result will also be binary in nature. Provides results as output. Let me try to explain it everything, what we mean by multipurpose, what we mean by programmable, what we mean by other terms, and how actually we do all, or how actually a microprocessor does all these things. Let us again think about computers. What are computers? What are the basic building blocks of a computer? We have a processor. We have a processor or a microprocessor, and then we have two things. We have memory. We have memory in our computers. Let me try to do it again. Okay, so this is our microprocessor and this is our memory. In a basic computer system, there's a program written on this memory, and this processor, this actually reads instructions from memory and executes them one by one. And also there are peripherals, there are input devices from which data goes to microcontroller. Input, and after processing this data according to these instructions read from memory, we get some output. I think that's fine. This is the basic computer system. We all know basic blocks: processor, input output peripherals, and memory. Apart from that, we also have bus. Bus are actually wires through which information is transmitted from memory to processor or input output to processors. And this bus can actually be of three types. There can be data bus, which is used to transmit data either from memory to microprocessor or processor to memory, or from input to processor or processor to output. There is also address bus. Address bus is actually used to read a specific address of the memory. I have to read something from the memory, but process sends the address of that particular memory, and then the data present in that address is read by the processor. Because memory can be thought of like pages in a book, so we need to know which page we have to read. There's a page number. Similarly here, memory is usually designed in byte addressable memory. So each byte is actually 8 bits, so we can write 8 different binary digits on it, and each byte has its own name or own number. So maybe this is 0, this is 1, this 2, this 3, memory location 3, memory location 4, memory location 5, and so on. So whenever I have to read a particular memory location, microprocessor sends an address using the address bus, and then the data present on that memory location actually is sent to microprocessor using data bus. There is another bus known as control bus, which actually used for control signals. I may explain it later. So one thing, we often have heard about a term or about a phrase that this is a 32-bit microprocessor, or this is a 16-bit microprocessor, or this is a 64-bit microprocessor. First of all, what's a bit? It's actually a short form of binary digit. Since these microprocessors are digital electronic devices, they only understand two binary digits, and they only understand binary numbers 0 and 1, and these are actually two different voltage levels. This is one voltage level and this is a different voltage level. So binary digit, the short form is bit. So what do we understand by a 32-bit, a 16-bit, or 64-bit microprocessor? This is actually known as word length of a microprocessor. Word length. It actually determines how many bits at a once can a microprocessor recognize and process. How many bits of an information can a microcontroller recognize and process? Some microcontrollers, they only recognize 8 bits at a time. So any incoming data should only be 8 bits wide. If it is more than 8 bits wide, it should be broken down in the chunks of 8 bits. So that microcontroller will be called as 8-bit microcontroller, and its word length is 8. Similarly, if a microcontroller understands, recognizes, and can process 16 bits at a time, it's actually known as, its word length is 16 bits and known as 16-bit microprocessor. Naturally, the higher the number of the higher the word length of a microprocessor, faster it will be, because then it will process the data more quickly. Okay, so now we know what we there are some terms, programmable. Let me explain what exactly we mean by programmable device. Let's get back to our digital electronics. We have a circuit, or maybe we have to design a circuit. We are given some inputs and some outputs. Basically, we have been given a word, a truth table. So it's given that we have 3 inputs A, B, C, and we have 2 outputs X and Y. So basically, and we have been given the various combinations. There will be 8 different combinations. You might be remembering this from your digital electronics. One, 1, 0 and 1, 1, 1. So I will put the outputs randomly. Maybe we have 1, 1, 1, 1, 0, 0, 1, 1, and Y should be 0, 1, 0, 1, 1, 1, 1, 0. Is that okay? So we have to design the circuit for this. I will try to design it. First of all, what we do, K maps. So I will make a K map for X first. You might do it differently. A, B, C. So output is 1, 1, 1, 1, 1, 1, 1, 1, and 0, 0, 1, 1. So this is the K map. I hope you might be remembering this. So I will group the elements. There will be a bigger group of maybe this 4, and then there will be another group like this. So I hope I remember it. I will try to write the equation. So our x will actually be equal to, for this blue one, it will be equal to a bar plus this green one, it will be a bar plus b. So this is our x. And now I will try to do the same for y. We have a b c 0 0 0 1 1 1 1 0 0 1. So our b is 0 1 0 1 0 1 0 1 and 0 1 0 1 and 1 1 1 0 1 1 1 1 0. Okay, so it's a bit complex. To make it easy, let me put a 1 here also. So there will be 1 here also. 1 is here, and I have 1 here then. So let me again try to group them. We will be again having two groups of 4s, one this and another one. So the equation y will be equal to a plus c. Okay, fine. So if I have to design the circuit for it, I will simply these are my inputs a, b and c. So my x will be equal to a bar. Here I will get a bar. So I have OR gate. I will be having an OR gate here. This will be my x, and then I have a and c. This will be my y. Or this thing I can represent basically as a block, and I can call that this is an electronic digital device that accepts binary data as input in terms of a, b and c, and according to the hardware inside processes the input and gives the output as x and y. For example, if the input is 0 0 and 0, I get output as 1 and 0, and similarly if the input is 1 0 0 0, I get output as 0 and 1. So this is somewhat similar to our microprocessor, but how is microprocessor different? In this electronic circuit there are no instructions inside, there are gates, and the decision is taken by the gates. But in a microprocessor we might have same three inputs a, b and c. They will be input to our microprocessor. Microprocessor will read this data, and depending upon what is the data and what are the instructions, those instructions we have written in the memory, we will have some specific output. Now why we call it programmable? What if tomorrow maybe a single output changes? For example, there might not be a 1 here, there will be a 0. So we have to make the Karnaugh maps again, and then we might be getting a different gate. The design may be different, so we have to change the whole hardware. But if we had implemented the same system using a microprocessor, we only have to change the instructions. That is, we have to reprogram it, we have to rewrite the instructions. So microprocessor, in comparison to basic electronic devices, it is a programmable device. We can change the instructions, and basically depending upon those instructions, it processes the input data. So I think the basic definition of microprocessor is now more clear. It's a multiple press device. It can do many things like addition, subtraction, logic operations like and or. It's programmable. It's clock driven. That means there's basically a clock which actually determines the speed at which the instructions are executed by the processor. It's register based. What we mean by register based, registers are actually memories. Registers are used inside a microprocessor, as we may see in coming lectures, to hold temporary data during the processing of information. So there might be many registers inside a microprocessor, and it's an electronic device. Then other things are clear. It reads binary instructions from storage memory, accepts binary input, processes this input according to the instructions, and provides results as output. So I think many of the things are clear now. I may like to move on a little bit. So the next thing, let us see what is inside actually a microprocessor. A basic microprocessor might have these things. Let me change my pen 1 second. One of the most basic things inside a microprocessor is the arithmetic and logic unit. We have an arithmetic and logic unit inside a microprocessor. Then we also have registers. We call it register array. It's an array of registers. The third thing we have control signals or control unit. Then this microprocessor actually communicates with other things using a system bus. At the one end, it communicates with what we call as memory, while instructions are stored. I am very poor at drawing, please excuse me my drawing skills. And then we also have input output device, IO. And this is the system bus, which actually can be control bus plus memory bus plus address bus. And actually now I will try to explain what ALU is, register array is, or control is. ALU is actually that area of the microprocessor where actual computing is done, where actual computing is performed. These are electronic circuits, maybe adders, maybe subtractors, maybe shift registers, electronic circuits. That perform arithmetic arithmetic operations like addition and subtraction, like add and subtract, sub, subtract, and also logic operations like and, or, XOR, etc. So inside a processor we have an arithmetic and logic unit, and there are electronic circuits. They might be gates which actually perform arithmetic operations like add, subtract, and many other operations, and also logic operations and, or, XOR, which operation to perform, which actually will be determined by what type of instruction is currently being executed. And then we have register arrays. I have already explained what are arrays. There may be different arrays, and we usually name them using English alphabets A, B, C, D, E. And some of these arrays, they have a special function. We'll be going to discuss that later. And some are general purpose. They simply store some of the intermediate data during the processing, or during operations like addition and subtraction. And then there's a control unit. The control unit actually provides the necessary control signals, timing and control signals, to all the operations inside this processor. It controls the flow of the data between the processor and memory, and also between the processor and peripherals. So I think things are becoming more and more clear. Let me once again explain the different components inside a system. Now I think we have 5 components. We have microprocessor, we have memory, we have input device, we have output device, and we have bus. What's the job of microprocessor? It reads instructions from memory. It communicates with peripherals and memory. It communicates with peripherals and memory using the system bus. It has a control. It actually has a control unit which actually controls the timing of the information flow, and most importantly, it performs the computing tasks specified in the program, like addition, subtraction, and, or, XOR. What's the function of memory? It stores binary information, and we call them as instructions, and it also stores data. And then it provides these instructions and data to the microprocessor on the request of microprocessor. And sometimes it may also store the result after a certain operation is done inside a microprocessor. What's the function of input devices? Using input devices, we actually enter data. That is to be processed by the microprocessor. And output devices, after processing the data according to the instruction in the memory, whatever the results, they might get displayed on the output devices. And what's the function of the bus? Bus carries these bits of information, these bits, zeros and ones, between processors and memory and various peripherals, that's input output devices. One last thing I want to discuss in this lecture is actually about language. How we communicate with microprocessors or with any programming equipment, programming device. You might have heard about the language, machine language, assembly language, and high level language. They are actually ways how we communicate with a programmable device. You might have already studied about these things, I'm sure. There are machine language are actually zeros and ones, because our devices, our microprocessors, our programmable devices, they are digital devices. They only understand zeros and ones. So actually we must communicate with them using these zeros and ones also. These zeros and ones will actually determine inside a microprocessor when to add, what to add, when to subtract, when to do an AND operation, and many other things. It actually will determine the sequence of instructions happening inside the arithmetic and logic unit of processor, and these instructions will be stored inside the memory. But since writing these instructions is very tedious for a programmer, for a human being, we created mnemonics for each of these instructions. A separate mnemonic is, for example, there for add, a separate mnemonic is there for an increment, and these mnemonics are actually English codes, symbolic codes that are actually in English language and more easy to remember. For example, we might have in 8085, in our microprocessor we are going to study 8085 is the microprocessor we actually are going to study about. It is actually the one of the oldest microprocessors. We'll be discussing this in more detail in next lecture. So one of the instructions it has is known as add. It's actually a mnemonic. It might have a certain machine code. For example, its machine code is 10000010. So whenever we write add, an assembler and a compiler will change this add into zeros and ones, and these zeros and ones will actually be written to the memory. But since it is easy for human beings, for us to write the programs using these mnemonics, we often use them, and this type of language is known as assembly language. There is also, and both of these, machine language and assembly language, they are microprocessor specific. If we are doing programming for 8085 microprocessor, we might have a certain type of set of mnemonics. But if we change our microprocessor, we move to some other microprocessor, the instructions may change, these mnemonics may change. For example, in 8085 mnemonic for addition, 8085 microprocessor, for addition we have the mnemonic ADD. But in some other microprocessor, for the same function, for the same operation add, we might have an instructions like add add as mnemonic for addition. So they are very microprocessor specific, and these two languages, machine language and assembly language, they are called a low level language. On the other hand, we also have high level languages. They are maybe C, C++, Pascal, Java. We might write programs in those also, and then an interpreter and then a compiler and assembler may also change those high level languages into zeros and ones. So finally, when we have to write the program inside the memory of a microprocessor, that must be in zeros and ones. But is simply to make job easier for a programmer, we have created these mnemonics, and we call this as machine language programming. Sorry, assembly language programming. Machine language is when we write in zeros and ones. So I think that's it for today's lecture. Our next lecture will actually formally introduce 8085 microprocessor, and we might start with its programming model. What exactly is programming model? We'll discuss that in next lecture. Thank you.